This is Horned Frog Engineering. This is the LT Spice analysis of the problem we previously did with mesh analysis and nodal analysis. This is the problem over here, and you can see it can be pretty complicated if you're looking at for the first time. But when we use mesh and nodal analysis for V1, we got the answer of negative 103, negative 103.8 volts. So we're just gonna use LT Spice. My professor always wanted us to use LT Spice to check our work. So that's what we're gonna do, is we're gonna use LT Spice and make sure that we got the same answer using LT Spice. So the first thing that we're gonna do is start with the easy one, which is set up the or put the voltage independent source. You can press this button or press V in your calculator, or not calculator, sorry, your keyboard. And in our case, V is 100. And then we have a voltage controlled voltage source, and that's gonna be, we're gonna press P for component, or you can go to edit and press P, but we're just gonna press P the component. For this one, a voltage controlled voltage source is letter E, and we're gonna place that right there. We'll put the values on there later. And then the next one is we're gonna set up this voltage controlled current source, and that is going to be letter G, voltage controlled voltage source. We're just going to leave room for the resistors. I'm actually going to move this over here just a little bit more, just to make room. And then the next one is a voltage or current controlled voltage source, which is, let's see, double check. This is a 100. We'll set up the values later on. This is the current controlled voltage source, and that's going to be letter H over here on this side. And then we're going to set up our resistors. We need to orient it rightly, so press control, hold control, press R, rotate it until it's on the right orientation. We have another resistor here, and a resistor right here, and then a resistor on top. And then we're also going to set up our ground. I'm just going to press G on my keyboard, because if you don't set up your ground, the LT Spice will not analyze it properly. And now we're going to set up the wires. The value for this resistor is 50. This is 20. This one is 30. And this one is 45. 45, 30, 20, just double checking, 50, 100 volts. And then we need to connect this ground. Can't forget that. Make sure that there's a dot right here. If not, there's not a dot there, then that means your ground is not connected, and LT Spice is not going to evaluate this rightly. So now we're going to set up our nodes, and this node right here, we're going to call that, we're just going to put 1 right here. You can press this .net or press N on your keyboard, and we're just going to put 1 right here. And then for this node, let's name it 2. So we have this node covered, ground node covered, this node covered, and then we want to get this node covered. So let's put 3. Let's name that one 3. And then we could name this one 4. Okay, so probably the most complicated part in this problem is setting up these dependent sources. So let's start left. Let's go left to right. This is 5i2, and the way we're going to do this is, apologies. Okay, we're going to put the value right here. Well, first of all, we need to this current controlled voltage source is dependent on the current I2 that's going through this resistor. We're going to need to set up a 0 volts, an independent voltage source over here with 0 volts. So it's just going to be a wire, and we want the positive terminal. We want the current going into the positive terminal, and in this case the current I2 is going right to left. We want that current to be going into the positive terminal so that the LT Spice evaluates it correctly. And then for the value, we're going to put 0 volts. It's just a wire. And then this component is dependent on the current going through this voltage source. So we're going to put V2 space, and you're going to put the number of your gain factor, which is 5, and that finishes this dependent source. And now we're going to go to this voltage controlled current source, and this is dependent on V1. First, let's edit the value. The gain factor is 0.02, 0.02, 0.02. We're going to put that there. And then V1 is defined by the voltage from here to here, this voltage difference. So it's going to be node 1 and node 2, and the positive side is going to be node 1. So we're going to put node 1. If you don't know the shortcuts, then you can just put label net and then put 1 right here, because it's the positive side, and then we're going to put another one here, but in this case this is not 1, so make sure you edit that, and this is number 2. The negative is at number 2, and this is at number 2 right here. So that sets up our voltage controlled current source. And the last thing that we need to do is we need to set up this voltage controlled voltage source, and we're going to do the same thing. The gain factor on this one is 0.2. 0.2 is our gain factor, not 0.02, so be careful. It's 0.2. And then it's dependent on V3, and V3 is pretty much defined as the voltage from here, from this node to this node. So in our case, it's going to devote the voltage from 1 to 3. So let's do that again. Set up the node 1. I'm going to put a 3 right there. And then next thing you want to do is do a DC analysis dot up. And then let's see, V1, the answer that we got for our mesh and nodal analysis was -103. So V1 is defined as the voltage in this node minus the voltage in this node. So it's the voltage at 1 minus the voltage at node 2. So the voltage at 1 is -3.8. We're just going to round up. -3.8 minus 100. So the answer is -103.2, which is coincides with our answers previously. And that is how you do the LT Spice analysis for this problem. You can go ahead and copy and do Control-C to copy, and then go to text, and then you can put the information right here. I know that my professor usually wanted us to have these LT SPI circuits annotated and put it in our Word document, so this is a clean way to do it, and we got the right answer. Well, thank you for watching.